Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're going to look today at covalent bonding. We looked at ionic yesterday, so today we're looking at covalent. And this is basically a review from last year, so just to make sure that you're in the right place. Covalent bonding is bonding due to sharing electron pairs. We defined that before, and we do that through Lewis structure. Now there's specific steps we go through to do Lewis structure. First thing we do, identify all valence electrons. Remember that off the periodic chart. 1, 2, 3, 4, 5, 6, 7, and because they're all non-metal, covalent, it's coming on this side of the chart. Identify the center atom, that's the one that's least of. Place outer elements around it. Bond the elements. And then fill outer elements. That means if we have 2 at the bond, we're going to need 6 more to make 8. Extra electrons go on the center atom. If we have extras, they go in the center. If there's not enough, then we double bond and we may end up with resonance structure. And that is our set of rules we have there. Now, let's do one. Let's do a simple one, water. So H2O, hydrogen's here. That's the first column. So we have 1. There's 2 of them. So that's 2 valence electrons. Oxygen, 1, 2, 3, 4, 5, 6. We have 6 valence electrons. 2 plus 6 is 8 electrons. We have 8 electrons to work with of hydrogen and oxygen. Hydrogen's our least numbers. We put O down. Now, we'll arrange it like this. We'll talk about molecular geometry and bonding geometry. This matters now, so you have to make sure you set up right. This is the structure it's supposed to be in. We're going to use 2 electrons at each bond. So 1, 2, 3, 4. Subtract that away. Leaving me 4. Now, we would usually put on the outside of hydrogen, but hydrogen is happy with 2, so we're totally good there. So those are extras. Extras go on the center. So we end up with hydrogen's happy, oxygen has 8, it's happy, so that's the structure. We can also do it with lines instead of dots if you like, and most students I find like that prefer. So we look like that with lines. All right, so let's take a look at a couple of these. Pause the video, try these yourselves. Remember when we go back about double bonding, remember about resonance structure, okay? All right, here we go. For ammonia, we have 8 electrons. Nitrogen's the center, hydrogen goes around, bond up, 1, 2, 3, 4, 5, 6, subtract it away, 2 left over. Hydrogen's happy with 2, so we don't have to worry about those. That means those are extra on the center. Nitrogen now has 8, we're good. Let's go to carbon dioxide. Carbon has 4, oxygen, 1, 2, 3, 4, there's carbon. Oxygen has 6 times 2 is 12. So it gives us 16 electrons. Carbon's my center. Bond up, 1, 2, 3, 4, subtract away. 12 electrons around. So we put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. We're all out of electrons. So carbon's not happy, doesn't have 8 yet, only has 4. So we're going to have to double bond. So we're going to take one of the pairs and move it to the bond. Now carbon has 6, still not enough. So we're going to double bond the other side. Now carbon's happy. Now sulfur dioxide, SO2. We have 18 electrons to work with. Sulfur is over here at 6 and oxygen's above it. So 2 times 6 is 12 and 6 plus 6 more is 18. So that's our arrangement. We bond up, subtract 4 away, 14. 12 around, 2 extras. That means it goes on the sulfur. Sulfur's still not happy, so we have to double bond. But could we have done the other side? Yes, we could. So we have to show that. In reality, it's in both places at the same time. So what we do is put an arrow between that, and that's what we call resonance. Okay. Now, there are 2 other ones I want to look at here. First is called krypton dichloride. It is a noble gas, but it is working with a halogen that's so electronegative it's making a bond. So we have 8 for our krypton, 14, 7 times 2, 14. 14 plus 8 is 22 electrons to work with. So krypton's the center, chlorine on both sides, subtract 4 away. Leaves us with the 18, put 6 on each one, leaves 6 to go, put those around the center. That's what we refer to as a superoctet if it has more than 8 electrons on the outer shell. Now let's look at phosphate, PO4, 3 minus. Okay, so we're going to have 5 for phosphorus, 1, 2, 3, 4, 5. Right, there's phosphorus. Oxygen, we said before, 6 times 4 is 24. And that -3, if it's negative, we're going to add electrons. If it's positive, we'll subtract them. So we have 32 electrons to work with. Phosphorus is the center. put around there, but because it's charged, we're going to put brackets around it, and the charge, basically a Lewis structure. It's what we call a polyatomic ion because it's a covalent molecule with a charge. Alrighty, so pause the video, try all of these, see what you come up with. Okay, here we go. That's our answers, and I also included in there polar and nonpolar. Remember, if it has hydrogen, it's polar. If it doesn't have hydrogen, it's nonpolar. Octet has 8, superoctet more than 8. That's our structures. Now, there's one more thing I'm going to talk about here, and that is look at geometry, bonding geometry. We talked about this last year. You can pause the video after I put this up right here. That shows all the hybridizations, the mutated orbitals that cause covalent bonding, molecular geometry, bonding geometry, and the bond angles. I didn't cover bond angles. I'm going to show a video of each of these. So let's start with the first one, linear. Linear looks like this, right there, straight across. Okay. Trigonoplanar looks like this. So it looks like a Y. Okay. Pause me if you need to look at it more directly. Bent looks like this. Just take one of the legs off the Y. And because those electrons, it's a little bit greater than 128, so spread out more. Tetrahedral. Oh, make sure I hit the button. There it is, tetrahedral. There we go. Look like a jack in my estimation. The game you play with a rubber ball. And then trigonal pyramidal. If I can hit that one. There we go. Oop, that's more bent. Okay, let's get that. That's one down here for bent. Trigonal pyramidal. Let's see if I can get that one to come in. Yeah, there it is. So we lost one of the top of the jack there. All right, now we get a trigonal bipyramidal. Trigonal bipyramidal looks like a Y with a top and a bottom on it. Seesaw, also called bent cross or irregular tetrahedral. Some professors don't like seesaw, they think it's too childish. There we go, that's that structure. T-shape, that one's pretty straightforward. There we go. And then linear, right there. Okay, now the last set, octahedral. There we go. Square pyramidal. There we go. Square planar. There we go. T-shaped again. And then back again to linear. All right, so those are molecular geometry and bonding geometries. Pause the video, record the sheet down. The shape you see here is the bonding geometry. Molecular geometry is always the same. It gives us the basis, and we work from there to get the other structure. All right, that's it. Hopefully not too bad. Take care. God bless. Bye.